My talk is about Akka cluster management and split brain resolution. So we already have seen who of you is using Akka, who of you is using Akka cluster. Okay, not that much anymore. Who of you has brought it into production and had to use something like a split brain resolver? Okay, so let's see. A famous quote is one microservice is no microservice, they come in systems. We already have seen this. Jonas Bonheur, creator of Akka, mentioned it a lot of times. And sooner or later, if you use Akka, you will come to that point when you need a cluster, when you have to spread over several nodes because you maybe need the compute power of more than a single node. Or if you use Akka persistence, for example, and your state does not fit on one node anymore, then you also need a cluster. Or maybe it's just for fault tolerance. So that's when you will end up with an Akka cluster. And the nice thing is that Akka already brings a lot to the table. So you have Akka cluster itself has a gossip protocol where it handles the cluster membership for you. So the gossip itself is the nodes communicate with each other in this gossip protocol and handle the membership state. The membership state itself is a CRDT, which we heard this morning already what it is. So it converges over time locally at each node. And you can, so each node, if it has, there is a scene state in this membership, and if a node has in the scene state all other nodes of the cluster, it knows that this state is converged at the moment. So, yes, but convergence cannot occur if there is an unreachable node. Because if there is an unreachable node, this node will not see the current cluster state. That means during network partition, it's not possible to add new nodes to the cluster or remove nodes from the cluster. Then Akka has a failure detector, which is, so in the cluster itself, it the nodes communicate with heartbeats. And if one node is not reacting to heartbeats, it's marked as unreachable by the failure detector. And also the failure detector is, will detect if a node becomes reachable again. In the cluster, there is one leader. There is no leader election in Akka. It's a deterministically algorithm. And the leader is there for changing the states of nodes from joining to up or from leaving to removed. And we have seed nodes, it's the communication points when you start up the cluster where you try to ask, okay, I'd like to join the cluster. So let's see, this is a part of the membership lifecycle. So you see, when a node starts up, it has the seed nodes and then asks all seed nodes, and the first that answers gets this join request from the node. And then it's part of this membership CRDT, and it's in the state joining. And if all other cluster members have seen that, the leader will change it to the up state. And in the up state, it's working. It's part of the cluster, everything is fine, everything is running. And then, yeah, eventually, maybe for whatever reason, it wants to leave. So it asks the cluster, yeah, to leave. And then it's in the state leaving. And at this state, it's also that all other members need to see that this node wants to leave. And just then the leader can move it to exiting. And if all other members have seen that it's in the exiting state, the leader will remove it. And that's the happy path. So if nothing goes wrong, That's the normal life cycle. So let's see a bit how this looks like. Yeah, sorry. So seed nodes can be configured in the normal application configuration. You can also join the seed nodes with a JMX or with a cluster management tool provided by Akka. So you can do it manually by hand, or you can do it in code. If you go and say cluster, join the seed nodes, and then you give a list of seed nodes. Sorry. One thing, the first node that's given in the seed nodes will be the leader. So be careful if you start up a cluster, there should only be, always be the same node as the first node. If you're on a side of, or if there is a split between the clusters and a node comes up and has itself in the seed nodes at the very beginning, then it will get the leader. So this is a part where you have to be a bit more careful. Good thing is to wait for the cluster, because if you start and say, okay, I join the cluster and then I start to do my stuff, it's maybe not that good because you're not part of the cluster immediately. You have to wait until the leader says, okay, you're now part of it. So when starting a cluster, you have the possibility to say, okay, there has to be at least this number of members until a cluster is really called a cluster. So maybe you say, okay, only if there are at least 4 nodes, you can start doing your stuff. You also can use the roles for that. So, for example, if you also connect to a message queue like Kafka, you should just start processing jobs from Kafka if you really were promoted to up from the leader of the cluster. This is how you can do it. You just register on member up and then start all your actors in this part. And then there is the leaving. Sorry. So as a good member of the cluster, you want to leave the cluster gracefully. You can do this too with, manually with JMX or the cluster management tool provided by Akka. And you can also do that in code, where you leave with your own address. You should add a shutdown hook, because if your JVM crashes, for example, then maybe you have the time in the shutdown hook to leave the cluster gracefully. If you have a split brain resolver, just as a side note, others will mark you as down, so you're not part of the cluster anymore, but nevertheless it's better if you leave gracefully. And there is also a handler you can register, this register on memory moved. So if you were removed from the cluster as node, you have the time to terminate the actor system, because otherwise the actor system would still run. So you're not part of the cluster anymore, but your actor system is still running. So this is how you can exit the JVM process. And in Akka 2.5, the upcoming version, there is a coordinated shutdown, which does all that for you. So if you have not something special to clean up, for example, closing connections or whatever, that you don't need to leave the cluster anymore, because Akka does all this for you. So if you just do a Control-C and kill your application, it already has this shutdown hook and gracefully leaves the cluster. So we're done. Yeah, we have an Akka cluster. Everything is working. Everything is fine. And then you see this. So to explain a bit, this is a log where you can see, okay, the leader is currently not perform its duties because reachability status, there is one unreachable member. No, that's not good. Why is that? Okay, we already heard about the CAP theorem this morning in the CRDT. So it's the same problem here. We have a distributed system, and there can, partitions is something we have to take care of. And the problem is here that network partitions are undistinguishable from, for example, if the node has crashed or it is just a network partition. You cannot really distinguish this. You also don't know, is it just a temporary failure or a permanent one? And it also could be that just the process is unresponsive. I mean, we are on JVM. If there is a garbage collection pause, it could be that it's just unresponsiveness for a moment. And Akka then detects this by no reply in a given time for the heartbeats, and then it's marked by the failure detector as unreachable. And as I said, also the failure detector is then responsible for maybe detecting it as reachable again. Or it will not come back. So we need some kind of split brain resolution for this. There are already some split brain resolvers if you have a lightband subscription. For example, you can use the static quorum, which is kind of good if you have a really fixed number of nodes. Your cluster is more or less static. And it also has some drawbacks. For example, you should start the nodes all at the same time, because if you only start one node, then it thinks it's not in the, it does not see the other, which should be in the static quorum, and will shut down immediately. We have the majority algorithm. So if you're part of the cluster which can see most of the members, so the majority of the other members, then you keep running. And if you just see a small part of the cluster, then you're in the minority, and you shut down yourself and all other nodes on the minority part, which also has some risks. For example, if there is a partition between a partition on two sides, then you have 3 clusters, and it could happen if they're equally. If the split is equally, then you have 1/3 in each part, and then all parts will shut down themselves. So yeah, the keep oldest is interesting because on the oldest member in the Akka cluster, there is always the cluster singleton instance running, if you use cluster sharding, for example. But it also has some risks. So if you have 100 nodes and there is a split where your oldest member is running and maybe 1 or 2 others, you maybe lose 97 nodes then. So yeah. Another thing is keep referee. So you just say this node has some important resources for me. So this node is always, or should be, is the one which I need. So all nodes in that part of the cluster are considered as up in a split brain scenario, and all others could down themselves. So this is, they're provided by Lightband. You just have to read through the docs if they fit your needs. But Akka also allows to bring your own split brain resolver. So for this, let's look again at the membership lifecycle. That's another part of it. We will focus on that. There is this new unreachable state. I already said there is the failure detector, which says from each cluster state, a node can be flagged as unreachable if the failure detector detects there are no heartbeats anymore, for example. But it's not really a state, it's just a flag. That's why there is this asterisk. And from this, if the failure detector says, okay, it's reachable again, then it goes to the previous state, so up, for example. Or you need to move it to down. And if you move it to down, you can see you go to the removed state then. And as I said before, if there are nodes flagged as unreachable, the cluster is not in a convergent state and does not work anymore in the sense of I can add new nodes or remove nodes. So this is not a desirable state we want to have over a longer time. So we can use this to implement this knowledge to implement our own cluster split brain resolver. And let's see what we can do. We can register for cluster events. So you can just go grab the cluster and subscribe to the cluster for domain events. And as a good citizen, when we stop, we also unsubscribe. Then we will get in our receive function, we will get the cluster domain events. And these are some of it. So for example, we have the member up. So each time a new member is promoted to up from the leader, we will get this message. We have the member weekly up. What this exactly is, we will see soon. We have the unreachable members. So if one failure detector detects a node as unreachable, all cluster nodes will be informed about that. And we will get that event. So we see which member is unreachable. And the member removed if a member is really promoted to remove. So it left maybe gracefully or was put down by other nodes. We will see how this works. And Akka provides us a cluster state we can get via the cluster and then just state. And here you see, which is really nice, we have always all the members of the cluster, which at least were at some point in time part of the cluster and are not removed. They could be unreachable, for example, or in another state, but they're still part of the cluster. Then we have this other set of unreachable nodes. So in our cluster state, this is the CRDT I talked about earlier. So in this cluster state, we always have the unreachable member set. And we have this seen by, which is used for the convergence. So if all members are also part of this set, we know this has converged. We're in a convergent state, which should mean that there are no unreachable members at this point of time. And also we can ask for the leader, and if we use roles, we also have a role leader map. With this, for example, we could implement a health indicator, so exposing the health state, which could be nice to have for monitoring our application. And when are we healthy? We are healthy if there are no unreachable members. At least the cluster part of our application is healthy then. So unreachable members, as I said before, are detected by the cluster failure detector. It can be fine-tuned in the configuration. So look in the Akka docs, there are a lot of things you can fine-tune. And they have a good description what things to, or what values to use. For example, if you run on AWS EC2 instances. So look at that. Then we have this leader cannot perform its duties, which means no new members can join in the case of unreachable members, as I said before. That does not really influence your application. It's just the cluster part. So the cluster, as I said, cannot add new members, cannot remove members, but your application is still running. But it means there is a network partition anywhere, so it could be that this influences your application running on top, but it does not really have to. Maybe it's just a temporary network partition. And unreachable members are still part of the cluster. So what I said before, it's not a desirable state to have these unreachable members for a long time in your cluster. So when we're talking about split brain resolution, we eventually want to remove them if they're not coming back. So we need to talk about downing. What we have seen previously here at this part, that we also can say if it's unreachable for a very long time, we manually down it. Downing, as I said before, will remove this member which you down from the cluster. And if it has some responsibilities, like if you use sharding with Akka persistence, other members will take over dead shards from that node. There is the possibility of auto-downing, which you can just enable if you have no Lightband subscription and you don't want to implement your own split brain resolver, then you can enable this, but it's highly unrecommended because yeah, you can end up in the end with each node performing its own or being its own leader, and then you have not a cluster anymore, but several nodes which always, all of them doing the same stuff, are thinking they're alone and doing or serving the same shards and so on. So it's really for development only. But every member can mark other members and itself as down by simply calling this down method from the cluster with the node address. So with the other node address or my own. And with this, we can already start thinking about how to implement a split brain resolver. We could write our own downing provider. So this auto-downing I mentioned before is nothing less than implementation of the downing provider, so we can implement our own and configure it in this with this config key. But we have seen before, it's just we listen for cluster events, so we can do this in any actor. It does not need to be a downing provider. And then we can use custom strategies around the cluster state, for example. If you think about majority, what is majority? Majority is if I see more reachable members than unreachable members, then I know I'm in in the part of the cluster that sees the majority of the rest of the cluster. If I see more unreachable than reachable, then I'm in the minority, so I could shut down myself. And there is another thing, we could use the weekly up state. For example, we could use, okay, what is the weekly up? If the cluster is in a network partition, then, as I said, no new node can join the cluster and is promoted to up by the leader, but it could still send a join message and the leader could promote it to weekly up, which means that this node is not really part of the cluster. It should not start processing messages, for example, and it's also not getting any shards from Akka persistent, but it's part of the cluster. So in the membership CRDT, I see this node as a member. And with this, or this is something you could also use for your custom split brain resolver. We will see that in an implementation we used in production. So you can see here this is this weekly up state, which is also from the joining. When a new node wants to join, then it can be promoted to weekly up by the leader, which happens if there is a split brain at the moment. So if there is a network partition, then the leader can, if you enable it, it's a configuration setting, if you enable weekly up, then the leader can promote a new node to the weekly up state. In Akka 2.5, this is enabled by default. Previous to that, it's disabled, but you can enable it. So let's see a custom split brain resolver we used in production. We had 2 data centers, and yeah, with 2 data centers, a majority algorithm is hard. You cannot really say, okay, if one data center is down, the other is in a majority because they're equally nodes. So you should have at least 3 data centers, then majority makes sense. So okay, we could not use that. Exactly. But we had, so the data center logic itself was, or had their own failover mechanism, which would move the nodes from one data center to the other, to the available data center. This, as I said, was a logic underneath. We were not in control of that, but the data center did this somehow magically. So detect which is still available and then started to move the nodes one after another from one side to the other. The problem is when the nodes are shifted to the still available data center, they come up as a new node in the sense of for the Akka cluster. So Akka cluster does not see this node as it is the same node as before. So for the cluster, it's a new node trying to join. But remember, we just lost this data center, so we're in a split brain scenario. The cluster membership has no convergence. We cannot add these nodes on this side to the cluster. But as I said before, we have this weekly up. So when they started up by the data center mechanisms, we can promote them to weekly up. And with this information, we could use with all the tools we have seen before, to implement our own split brain resolver, which we did. And more or less, this is what we did. We have a method which does the scheduler majority check. Yeah, if you're familiar with Akka, we just say, okay, in 7 seconds, send a check for majority message. And the check for majority itself looks like this. If we receive the message, there is no unreachable member, we do not need to check anything. We are in a convergent state, the cluster is working. Yeah. But if there are unreachable members, what we do is we check if so we take the unreachable set and we take the set of all members and build the difference from the unreachable set, which gives us only the reachable. Otherwise, we would have all members in this. So we have all reachables, means all in the state up, for example, and also all in the state weekly up. And if this reachable size is bigger than the unreachable size, we know we're in the majority part. We're in that part which is still available because the nodes from the other data center, which is marked as down, were moved to our side. So then we're in the majority. Otherwise, we would be equal. So if the reachable size and the unreachable size is exactly the same, then we're in the split brain scenario and the data center or the network partition just had happened. So then we don't know what to do. But if the data center logic started to shift one node to the other side, and we are in the side where we have where the reachable size is bigger than the unreachable size, we know, okay, we're in the still available side, and we just go and take the unreachable and tell them to down. So they will not get that, right? But we remove them from our cluster state. On the other side has the same problem, so the nodes are shut down one after each other. So the reachable side of that part will be getting less and less. So there will be fewer nodes. And when this happens, so after the first node, this side detects, okay, we're on the minority. So, okay, what do? We down ourselves. So the other side of the cluster, which is not in the available side, will also shut down itself. And then, here is the rest of the code. We have these known addresses. So if a member comes up, we just remember that node. If a member comes weakly up, we just take a look. If it is part of the unreachable nodes, then we down the one we had previously. So we remove that node, so the previous incarnation. And also, yeah, if there is a removed, we just remove it from the known addresses. Okay, and that's it. We have written our own split brain resolver, and we're done. Okay, thank you.